Welcome to Real Civil YouTube channel. In this video, I am going to show you the time history analysis, linear time history analysis option. Previously, we have done pushover analysis in the etab and their results. Those video can be you can watch in the description box. The link is there in the description box. Okay. So before starting the procedure, we need the data related to the modal time history, modal analysis data basically. So go to tables here, uh, structure output. Here we will require modal information and modal participation mass ratio, and that will be required for modal case, right? Now we will extract this data or in the form of Excel. Yes. Okay, so now we can start the time history analysis steps. So first step is we need to define the function. So time history is the option here. So other options I will discuss in some of my other lecture. So here you can select from file. So some ready-made time histories are available. Add new function. Here go to browse. So in your C drive, computer and structures or program files, computer and structures, etab 19 and time history function. So this is the path and you will reach to these time histories. Okay, so you have to select these the time history and you have to click on open. So I will show you what is there. I will open with notepad. Okay, so this is the data file and here time history function name. So the time history name is given here. Okay, so we have it gets automatically. Header line to skip. So actually the data starts from here. Okay, so first two lines are the information lines or header line. So we have to skip this. So here it will be 2. If there are more lines you can add more numbers, 2 3 4 5 depending upon each file. Prefix characteristics per line to skip. Here no any prefix characteristic is there. So you have to uh, put here the value 0 and then number of points per line. So if you see the file you can see here 1 2 3 4 5 6 7 8. So there are total 8 readings in a one line. So you can type here 8. Then values are here, two options are there, time and function value. Second, values at equal interval of. So we have direct values here, no any time is given. So all the values are spacing at a distance of 0.020 second. So values are at the equal interval of 0.020. So if you put this data then automatically this graph gets generated. Okay, so this is the time history we are going to put in the in our structure. So you can click on OK, your function is added here. Click on OK. Now go to define load case. In load cases, in previous lecture I have told how to define this dead load non-linear case. Okay, so you can just check out how we define the dead load non-linear case. or you can basically watch our previous video. Okay, on pushover analysis. So here I am going to add new load case of time history in x direction. Load case type will be time history. Now there are different ways to analyze the structure. So here basically I am showing you the linear option. So you can go with linear direct integration, and if you want non-linear analysis, I will make separate video on the non-linear time history analysis. So here you can click on linear direct integration. Then here P delta non-linear stiffness. Okay, so you can select loads at the end of the case, dead load non-linear, or you can basically go directly with the linear case also. So basically this option is useful for non-linear case. So here we will go with the linear direct integration. So we'll choose the linear option. uh, Load applied. So here you have to select the acceleration. Here u1, u2, u3, r1, r2, r3 options are available for direction and rotational. So we will go with u1. You have to select the default function which we have defined. Now the scale factor. So scale factor basically depends on the units. So if you see this, the unit is centimeter per second square, and if you go on the units of the acceleration, it is mm per second square. So we have to change the scale factor here. Okay. Also there is another way, you have to do this thing, and then later you can do another thing. There are some codal provisions are given like I by r factor you have to multiply. So in addition to this unit conversion factor, you can apply those factors also. Okay, then number of output time steps. So here you can see 2000 point data is there. So you can type here 2000 points, and each output is taken at 0.02. Okay, now here we have to specify the damping mass proportional coefficient and stiffness proportional coefficient. So we will go with specify damping by period. Now here you have to put the periods. So that's why I told you, here you can see these are the periods. Okay, so for x direction 0.7985, this one is major, so time is 1.084. So here you can type 1.084, and you need to second dominant period. Here the second dominant period in x direction is this one, 0.31. So here you can type 0.31, and damping is for concrete structure it is 0.05, and you can click on recalculate the coefficients. You can click on OK. For time integration you can keep this option as it is. Click on OK. Similarly, you can do this for time history in y direction. So we'll add the copy. Here we will make time history in y direction. Here we will make u2. Then here we have to put the time period in y direction. So dominant time period in y direction is 0. This is period 1.084. So this is almost symmetric, hence you can put 0.31. So both periods are same. So you can keep this thing as it is. You can click on OK. Click on OK again. Now we will run the case. We'll only run the time history case here, which is linear one. I will show you some of the results uh, related to the linear time history analysis. For nonlinear, you need to define the p delta effect, and along with the p delta effect you need to define the material nonlinearity or plastic hinges, so that it can give us the performance levels like immediate occupancy, life safety, collapse prevention, and etc. Now you can click on done. Now here we can see the results, response spectrum curve, and here you can see as we have given the 0.05% damping, but there are some other dampings are readily available. So these are the story wise response spectrum. Importantly, here you can see the plot functions. So these are the plot functions. So these are the values of the base shear in x direction and y direction. So this is how you can see the other results. If you change the scale factor, your values will going to change. So this importance of the scale factor is more here. So I hope the concept of time history is clear. Please like, share, subscribe the channel. Thank you so much for watching the video.